Alexandra, and I'm here to talk about pressure at a depth in a fluid. So I think we're all familiar with that when you dive into a swimming pool, the pressure is higher than at the bottom than it is at the top. Why is this? It all has to do with pressure at a depth in a fluid. So we have to understand that pressure is distributed evenly through a liquid only if external pressure is applied. Here I've drawn a cylinder, and in the cylinder is a thin piece of aluminum that takes up the entire cross section, and it is positioned at height h. The fluid is static, and we are going to imagine that there is no atmospheric pressure applied on it. So the net forces have to be 0 and the acceleration is 0. If the fluid is static, the piece of aluminum in the fluid is also static. In this situation, the force down is equal to the force up, and the force down is equal to the mass of the liquid times gravity. So we know that density is equal to mass over volume, which is measured in kilograms per meter cubed, and this can also be translated to mass equals density times volume. We can translate this to the other equation, which would make this force down is equal to density times volume times gravity, and volume is equal to height times area, which means force down is equal to density times height times area times gravity. The pressure downwards is equal to force over area, which means that density times height times area times gravity over area, and this can be simplified to pressure down equals density times height times gravity. The density of water is 1,000 kilograms per meter cubed. So if you dive into a pool, if you dive to the bottom of a pool that is 7 meters deep, the density that the pressure you would feel would be 1,000 times 7 times 9.8, which is equal to 68,600 pascals, and that is how you find pressure at a depth in a fluid.